So we've looked at calculating the sum of n terms in an arithmetic sequence using the formula which was presented in the previous video. What I'm going to do here, I'm going to give you a couple of questions. What I want you to do is pause the video, have a crack at the questions, then come back and check your working and answers with what I'm going to present here. So here you go. First question, I want the sum to 16 terms for the arithmetic sequence when I give you the first three terms here. And then the second one, slightly different. I want you to find the sum of the arithmetic sequence given by 2 plus 7 plus 12 plus 17 all the way up to plus 52. So pause the video and have a crack at both of those. So the first one, find the sum of the first 16 terms for this arithmetic sequence here. We know the formula we want is Sn is equal to a half n bracket 2a plus n minus 1 times d. Now for this to work, there's three things we need. We need to know n, how many terms, we need to know the a, and we need to know the d. Now the a and the d we get from the fact that un is equal to a plus n minus 1 times d. We're able to work it out from that and then put them into this formula here. Now we know that the a is given by the first term, so u1 is equal to a, which in this case is given by 7. We can then calculate d, which we know is the common difference between terms. So what I do is I calculate the difference between consecutive terms and see what that gives me. So if I look at these two, I do 28 take away 7, which gives me 21. If I then do these two terms here, I do 49 take away 28, which gives me 21 again. So my common difference here is 21. Now for this I also need to know n, but that is given by this here, the 16, because that's how many terms I'm going to. So I know that n is equal to 16. So I now have all the bits of information that I need, plug it on the formula, and you can calculate it through like that. So S16, the sum of the first 16 terms, is given by a half times 16, bracket 2a, so 2 times 7, plus n minus 1, which is 15, times the d, which is 21. So a half times 16, so half is 16, is just given by 8, so that's 8, bracket 2 times 7, which is 14, plus 15 times 21, which is 315. That means 8 times the sum of these two, which is 329. What that then gives me is 2,632. So there you go, the sum of the first 16 terms of that arithmetic sequence is 2,632. Fairly straightforward. We just have to remember this key step here, because these are the three bits of information that we need to know: the a, the d, and the n. Second question was find the sum of the arithmetic sequence given by 2 plus 7 plus 12 plus 17 all the way up to plus 52. Now for this, again, we want Sn equals a half times n brackets 2a plus the n minus 1 times d. Now again, we use the un equals a plus n minus 1 times d in order to be able to calculate the a and the d that we need for this formula. So u1, that gives me my a, what we know already, so that's going to be 2. I then look for the common difference, again look at the difference between consecutive terms. So 7 take away 2 gives me 5, 12 take away 7 gives me 5, 17 take away 12 gives me 5 again. So my common difference in this case is equal to 5. Now this is where the difference comes into play. I don't know how many terms I need to go to. All I know is the final term of the arithmetic sequence. So from this I need to figure out n. But I know that un, whatever the term I'm at, is equal to 52. Now that I know a and d, if I plug them into here and set it equal to the 52, I can work that through like a general equation to calculate n, which can then be used in the sum. So what I know is that a, which is 2, plus the n minus 1 times d, which is 5, equals 52. So if I multiply out the bracket, I get 5n take away 5. So I've got 5n minus 5 plus 2. So I get 5n minus 3 is equal to 52. That there, nice straightforward linear equation for us to be able to solve. 5n is equal to 55. N is equal to 11. So I know that the 52 here would occur when n is equal to 11, i.e. that would be the 11th term of our sequence. So now that I know all three bits of information, my a, my d, and my n, I can substitute it all into here and figure out what my sum is. So I know I'm doing the sum of the first 11 terms, so S11, and that's going to be given by a half times 11 bracket 2a, so 2 times 2, plus n minus 1, which is 10, times the d, which is 5. So that's then going to be a half times 11. Now I've got 2 2's, which are 4, 5 10's, which are 50. 50 plus 4 gives me 54. So I've got a half times 11 times 54. If I do all of that, I end up getting 297. So there you go, slightly different in that we didn't know how many terms we were going to, but nonetheless, still relatively straightforward because we know that we need the three bits of information there which are vital to calculating the sum. We need to know the a, we need to know the common difference, and we need to know the number of terms that we are going to. Remember that whenever you're using this and whenever we're working with it, they're the three key bits of information that are always going to be utilised in this kind of question, regardless of the format and what the ultimate goal is. Always remember that. We need those bits of info to be able to do anything with this formula.